And Drift Week is brought to you by all these amazing sponsors, but this video in particular is brought to you by Vapetasia. This is the owner of Vapetasia, and we're going to talk to him about his passion project, which is his own machine shop, and I want to get information from him about engines and engine setups and my own engines in particular, so you guys can maybe learn something off this. So thank you so much. Please enjoy this episode. Thank you, Chris, for sharing all this info. Okay, so this is gonna sound bad, but Chris gives me the ideas to do scam interviews. So in this, we scammed Luke Fink into giving us advice for free on the track.
I'll take that.
This interview is about scamming advice out of him, which he probably has to tell people all the time. So he owns a machine shop, and I need to put an engine in a car that I'm going to ship to Ebisu. And I have an engine that I just got built by a shop and everything, but I kind of need another one for the same topic. I need a 400 to 450 wheel horsepower, LS-based, aluminum or iron, doesn't matter. The most reliable engine possible on pump gas. I am not as concerned with cost, although cost, the cheaper the better. So if I could do a stock long block LS3, that would be amazing. But I've seen a bunch of Corvettes here at Drift Week blow motors, like 2, I think, is that correct? 2 or 3?
Yeah, something like that, yeah.
So 2 or 3. I don't want to blow motors. I don't want to run an AccuSump. I don't want to run dry sump. I don't want a maintenance machine. Like, I think you see how I treat my car and all this stuff. Yeah. Like, we just drive my car through a tank of gas, put another tank of gas in it, and just keep going. I don't want to open the engine. I don't want, like, you know, the hood. So what do I do? What is the best idea? I want ultimate reliability for as long as possible, with enough power to drift. I don't need over, like, say, 7,000 RPM.
Yeah. So, I mean, like, you're not looking for a lot of RPM. I have this discussion all the time. You know, I definitely think that when it comes to engines from the factory, GMLS is one of the worst when it comes to the quality of the machining. But the engineers do a very phenomenal job of putting the package together and making it work, right? Like, and getting life out of it. But also, you have to factor any of these cars that this LS engine would come in, right? Like, they make a lot of low-end grunt, and they're geared to where they cruise on their highway at 1,500 RPM. I'm literally driving my Corvette, drive around at 1,500 RPM in 6th gear. When they're setting these engines up and they're building them and designing them for these cars, you know, the average RPM that they're expecting is considerably lower than what we're putting it through. I will say that, you know, you have a lot of choices and a lot of different directions you can go. The aftermarket support is endless. But I mean, realistically, for those power levels, I really feel like there's not a lot that needs to be done, especially on pump gas. You could technically, in theory, stick a stock LS3, or if you got a crate motor or something in your car, and go. The biggest failure point that I see is typically it starts with a camshaft. Probably the number one thing I see is, you know, call up Texas Speed or someone and give me the biggest cam you got. And then they wonder why they have problems. Or, you know, LS7's rev to this, you know, and I'm gonna use LS7 lifters. I take so many motors apart, and every single time someone comes in is like, no, I want to keep using LS7 lifters. They're amazing. They're the best. They handle this RPM in an LS7. They're factory GM. They're going to work great. And then it never fails. I tell them, I argue with them, and I realize I can't. I'm never going to get anywhere. And I open them up, and the lifters are trashed. Camshaft is trashed. Like, it just can't keep up. And realistically, it's just like anything else, right? Like, when we look at, you know, a lot of these import motors, like SR20s, why don't we like SR20s? What's the solution for an SR20? JZs, why do we like JZs so much out of the box? Why is the head so good? And it all goes back, everything circles back to a solid lifter configuration. And then I get to an LS, and it's like you spent years, you know, because a lot of the people I deal with drifting, they've gone through SR20s and they're over it, they're on to LS, right? That's a very common transition, you know, in the community, right? So, and so it's like everything points to doing this, and every application, every solution points to this, but then you get into LS and you don't want to deal with it. And you don't want to put solid lifters or upgrade those things in your engine.
Explain to me real quickly who's an idiot. What is a solid lifter? What is a hydraulic lifter? And why does it matter? And why are stock like SR so reliable on hydraulic lifters for so long, but then you say it's required to have a solid lifter all of a sudden?
Well, this goes back to engineering, right? Like, and same thing, and then also age, wear, things like that, right? Like, getting your hands on SR20 OEM lifters, not easy and quite expensive, especially now. I don't even know if they're still producing those things. But so a solid lifter or a hydraulic lifter is going to fill up with oil, pressurized oil, and that's what's going to keep your rocker, or in the case of V8, push rod, right? And that's what's going to take up the slack, right? And it's designed to where when that lifter takes up the slack, there's no lash. Like, so basically there's absolutely zero play between the rocker and the camshaft, or the push rod, whatever it may be, right? And then it takes up all that slack, and what it does is it reduces noise. It makes it easier long term. There's no real service intervals there. You don't have to, continue to go in and readjust to keep your tolerances, because it's always going to take up the slack. And like I say, like on an LS platform, right? Like, I even recommend, like, in my car, I don't even have solid lifters. My setup was like a little bit different. I was kind of in a hurry. I had the heads off, and I was working with a cam I already had. So we used Johnson short travels, and they're about, the entire travel of the lifter is about 57 thousandths, I believe is what it is. I'm not sure exactly what the number is, but it's close to 50 thousandths of travel in the entire lifter, right? In an OEM GM lifter, you have about 250 thousandths of travel, so 5 times more distance that lifter can cover, right? So the more lift you put into it, the more you compress that lifter during the cycle, the more it has to recover, the faster it has to recover. And at higher RPMs, they have a hard time recovering. So what happens is that lifter then can't keep up. And when it can't keep up and it doesn't collapse fast enough or expand fast enough to take the lash back out, it starts bouncing in between the camshaft, right? And then when you allow for that type of play, it does damage. And where, if you're on a solid lifter, it's completely rigid. Depending on the engine, you could have anywhere from 7-8 thousandths lash up to some of the wild stuff where 20-something thousandths, valve lash or clearance. The problem is it's noisier, right? So you get a constant, you have a little bit of play constantly, but you never have to worry about whether or not that thing can collapse, keep up, whatever. It's always there. You just have to check it periodically. And then from there, like, there's other variables in how you have to check them, like on an LS. Are you running shaft mount rockers? Are you running pedestal? Like, what type of rocker arm you're running? Are they aluminum? Things like that, because other things can deteriorate over time outside of the lifter, and you have to adjust periodically. But for the most part, I mean, in not so radical setups, there's no reason why you can't go season or more without checking that stuff. And if you really don't want to check your valve lash once a season or something like that, then you probably deserve, like, whatever damage is kind of coming your way.
Not to interrupt you, but I am.
Yeah.
Going back to the hydraulic lifters, why are they so reliable in SRs, and then what makes them not reliable?
And see, that's the thing is this is not, I don't think that they're reliable in SRs.
But I mean, they are really reliable when the cars are fairly stock, and then it's either time or modifications.
Now we go back to engineering, right?
Yeah.
And that's what the thing is everybody wants their cake and they want to eat it too. I got an SR, I want to raise my rev limit to 8,000, I want to put cams in it, and I want my stock lifters. Like, you can't have all of that, you know what I'm saying? It doesn't work. The lifter can't keep up.
But what if, like, say I'm looking for, again, we're talking about a really basic motor and everything, if I'm willing to keep the stock LS3 redline and I'm willing to, like, keep the stock cam because that motor might hit with long tubes, it's gonna hit like 430 wheel or something, right? Yeah. I can live within those design parameters. Can I keep those if I'm gonna stay within the design parameters so I have a maintenance-free engine?
I think that you can. I think that that's not unreasonable. I do know, like, this is more common. This is not very common with SRs. SR lifters, hydraulic lifters, are fairly good from the factory, and the range that they have to operate in, they're not compressing and expanding as such a large of a window as like a LS lifter would. So it's not working as hard as an LS because of the design. So you can. I do know on a lot of LS platforms, even factory ones, they have problems. I know, like, especially like the new 6.2s, but they go through series, over the years where, like, even factory lifters can fail. So, like, things can fail and you're racing. I would almost want to change that just from a reliability perspective. And kind of going back to the SR20, this is something I always talk about too. Like probably the dumbest thing I've ever heard of ever being invented or sold
rocker arm stoppers.
Is rocker arm stoppers. Is the absolute dumbest thing I've ever heard of. It's mind-blowing to me that became a thing and then continued on, right? Because you could only stop the rocker arm so much because you can't interfere with the rocker arm. You can't touch the rocker arm, so it has to stay off the rocker arm. And the failure point is that rocker arm depresses the lifter, and the lifter doesn't come back fast enough, leaving enough of a gap for that arm to pop out. And that's the big problem, right? And that's not, rocker arm stoppers cannot physically stop that. It's not possible. All it could do is just hold the rocker in place and cause damage. But I mean, you see it all the time with people launching rockers out of SRs, and obviously these are guys that have raised the rev limit or something is altered from factory, typically when you see that happening. But that is, if you look at the shim inside there and the guide, and how much room there is inside there, I mean, that rocker arm is got a pretty good amount of meat being held in place. So you got to think about how much that lifter has to collapse and how far behind it has to be from reopening back up and expanding back for those split seconds when you're up in the RPM for that rocker arm to just fall out and just slip right out. So I mean, like you said, you can't really like take a video camera and stick it inside your valve train while you're driving, but if you could, it's wild. Like if you ever see, like I know like it's probably not, but like there's like videos on YouTube of like people with spintrons with like cut engines and stuff like that, showing you like how much things move around, valve springs, how much they spin, and things like that. When you take that fraction of a second where it's at the top of a cycle and it's the loads off the spring, and it's like every single time when they slow it down, it's insane. You don't realize how much things move around. I do believe that the keys to success, like I mentioned to you, like Justin was on Drift Week, and it kind of looked like one of those setups that would never make it. But I knew it was going to make it because he was stock cam, and because that's
Justin
one of the
Hart
biggest
in the Turbo V8.
Yeah. It's one of those things where like the stock cam, like these things are engineered. Like these engineers go through a lot of trouble. I mean, the proof is in the pudding, right? Like you see these cars going 200,000-300,000 miles. Like how that's not possible if these things weren't well engineered. But the guy making your camshaft is not a GM or a Nissan engineer. You know what I'm saying? Like, these guys aren't engineers. The guy installing your camshaft, you're doing yourself. You're certainly not an engineer, right? Like, so like you're changing everything, right? You're putting LS7 lifters in your LS. Well, is the profile of the cam match an LS7? Are you running an LS7 cam? Like that's kind of what it boils down to. Like, and then you start crossing over into like the need for race car parts, like racing, like stuff designed to do this job. There is a million parts for an LS that are designed to take the kind of abuse you could throw at it. If you really don't want noise and you're really worried about a little bit of ticking, they make high-end hydraulic lifters. If you don't, and you just want it to be stone cold reliable, and you don't want to have to worry about nothing, and you're willing to do the occasional valve adjustment, which is really easy if you have adjustable rockers, then solid lifters are the way to go. This stuff is tried and true. I mean, there's formulas for everything. You can go all the way. I mean, you got to think like this. These pushrod V8s are used. NASCAR, short course, like, there's trucks, like, I mean, there's so many different forms of racing. So, like, there's a million recipes that you could follow out there for success, of what these guys actually use,
What should my recipe be?
So, I will say this, right? So, I know a lot of people feel like they need a built motor. It's not every application calls for that, right? I'm running one. I'm pushing my luck a little bit on power, and I enjoy it. I have a machine shop. It's a little bit different situation, But when you switch to things like hardened bearings and things like that, you get a lot of things like, detonation resistance, pistons. You get into a forged piston, you're getting into a heavier piston, but you're getting stronger ringlands, thicker ringlands, better rings, things of that nature, right? So as you get into aftermarket stuff, you get into much more durable items, like hardened bearings. They could take much more abuse, much more detonation, where if you were detonating really bad or something happened, it's not hard to crush and flatten a regular aluminum bearing or something. But from a longevity perspective, it's not it. right? You have to run much looser tolerances. Forged pistons expand and contrast a lot more. You have to compensate for a lot of things when you run these aftermarket parts that take away from the life expectancy of that. But it gives you a lot more margin for error if things are happening there, right? So then what it boils down to is like, how well is your car tuned? How is it dialed in? How well are you upkeeping it? How are you dealing with whether it's elevation changes or whatever? Are you having it tuned for the gas that's there? How on top of these things are you? Because in a lot of regards, you could, if you're not trying to go extreme RPM, get away with factory bottom end, a lot of factory parts if you're not really trying to exceed these parameters, and maybe something like a crate motor might be a better solution for you. I just took a picture instead of silencing my phone.
Do you need to look at who it is?
I don't care who it is. They could.
Okay.
It's spam. There, now I know.
I've had 2 spam calls while we get here.
Maybe I need an extended warranty on my LS.
So I keep pushing you on the same subject. Stock LS3, crate motor, or a built motor for my application? I'm asking you for me.
You only need four. You only need 400 something. And actually, this was a conversation I was going to have with you. I was actually having a conversation with you off camera, anyways, because I think that there's nothing wrong with crate motor in your application. I'd like to see maybe. I mean, the reality, if you're going to leave the factory cam and stuff like that, you could probably send it, man. Like, you could probably get a lot of life out of a brand new motor and be a lot happier, and it'd be a lot simpler. If you're going to open it up, I would recommend doing, mild cam and, a solid lifter and some adjustable rockers and stuff like that, and keeping up with it, because, these are things that aren't, if they fail, they're not major. You know what I'm saying? Like, let's just, because you always run that risk. You run the risk with OEM parts, but a lot of times with aftermarket parts, sometimes the quality control isn't there, or whatever it may be. You do run risk with the aftermarket parts. There typically is a little bit more exposure in that regard. So going to aftermarket parts, but like I said, we're talking about valve train items where, like, if a rocker or something was to break, you would have to stop driving and address it, but it wouldn't be like catastrophic, From a reliability standpoint, then it would give you the ability to maybe turn more RPMs and things like that. There's other things that are nice, like high volume oil pumps and things like that. There's things that you could do. Like I said, I think if you're going to stay within the factory parameters, I think it'd be crazy to even crack it open. You know what I'm saying? I think it doesn't make any sense. Like, if you're happy staying within the factory parameters, most guys, like I said, they want their stage 5 cam or whatever So is me drifting staying within the factory parameters? That's my question.
Again, we had a stock LS3 motor. It did have 70,000 miles on it, and multiple drift weeks, and it's been beat on.
Look, you're not going to get 300,000 miles out of the motor drifting. I mean, that's just the reality of it, But outside of something that would have failed in the first 100,000 miles, let's just say, and you take it out and you do a drift week on a motor, right? If something was going to fail, I feel like it would fail under normal conditions as well, right? And that's not uncommon for GM stuff either, right? Like I said, usually it's lifters or something stupid, but those things can fail at any given time, and you're racing, right? Like, nothing's perfect. You put your car on a racetrack, and this is another thing I've debated a lot too. I do not feel that there's another form of racing that's as tough on engines as drifting.
Drag racing, top fuel dragsters?
I mean, there's I guess maybe I could reword that, anything that would run on like ethanol or pump or, fuel, like gasoline, Like, I get like an alcohol car or something like that, But it's just, it's extreme. The amount of RPM, like, even we look at Circle Track, and I lean on Circle Track data a lot because I'm always searching for, like, horsepower thresholds and support, right? So nothing leaves my shop, or I don't do any assembly work on anything unless every part that's going in there is rated for that power and that application, right? So when I call these parts manufacturers, right, whatever, rod or pistons or whatever, and I tell them drifting, they're like, yeah, whatever. But if I say Circle Track, they're like, higher, like, they don't comprehend, right? But even that, like, I think drifting is even more taxing than that because of the amount of load that the car is under at those RPMs. It's extreme. especially like Formula Drift and stuff like that. It's a whole different ballgame. So we are putting a lot more stress and strain on the motor. Would I like to see a built motor for you and your application? Yes, right? Because I would like to see stronger parts. I would like to see margin for error. I would like to see these things, right? But if you're not going out with a team and spares, and you're not going out with, the understanding that you're going to have to tear this thing down, service it every season, go through it, and you know what I'm saying? Like if you're not treating it like a race, then no, then absolutely not. Then it would be kind of ridiculous to buy a built motor at that point. And I think if you're happy with those horsepower levels, then there's nothing wrong with a crate motor. I don't think there's any issues with that. Couple important things is if you do anything to this crate engine, use factory shit. Head bolts, factory.
Why is that?
I explain this all the time, and sometimes I often refer to it as like the lottery. So what happens is you have, on average, okay, so let's just go with LS, right? You have 0.7 of a thousand run out. That's allowable when they're finished machining that motor, right? And then it goes into assembly, right? And that's the specs that GM allows when they measure it and do their quality control before it goes to the next step and gets assembled, right? And that would be the same specs that would be there for a remanufacturer, rebuilder, machine shop, whatever, right? Is 0.7 of a thousandth of run out. Changing the clamping force and the load of a bolt or hardware changes things and shifts metal around and changes those numbers quite a bit, right? Depending on the block and the type of hardware, right? So you got an LS aluminum block. Those things shift quite a bit. It's not the craziest motor, but they do shift quite a bit.
When you say shift, what do you mean?
So the actual cylinders will move in size, change in size, alter in size, and twist and distort differently, right? And every block is going to be different. So you just don't know, right, what you're getting yourself into. Some LS blocks, we put standard ARP hardware in, they move 0.5 to a thousandth. But you're now out of that window of whatever factory spec is for allowable run out for piston to wall clearance. Mm-hmm. You've just lost that.
Is an iron block better than aluminum for that then?
Absolutely, it's more rigid, but they still, same problem, they'll shift. And like you go to like JZs. JZ, I get 0.9 to 1,000. Well, maybe some have been less, like 7/8 on standard hardware. On 625 hardware, almost 2,000s sometimes run out of movement. And just change of diameter of bore size from going from one set of hardware to the next. And it's crazy how much that moves. And if you try to do, I've heard things like, well, I'll take the ARP hardware and I'll use the factory torque sequence, but it's a completely different material. And these bolts are designed to stretch, and that's how they grab and they hold, right? And that's how the torque is determined, is by bolt stretch. So if you go to factory torque, you're not stretching the bolt properly, which means it might not grab, which means it could back out on you, which is even worse. So it's stupid, right? Like to use that kind of hardware. But the thing is like you get guys that, I have a guy in my shop, Trav, that was, when he first started working for me, he's like, oh man, I did ARP hardware for 4 years. And dude, fucking perfect. And I'm like, who knows? Like maybe it fucking shifts things back and makes it perfect again. Like it's the fucking lottery, because I know guys that put ARP hardware in their car and they're filling up catch cans the next day. You know?
I never thought about that.
It's crazy. Like,
so when you build a motor, do you use ARP stuff or you use?
Oh, 100%. But I have to be machining it.
Oh, I see. Okay.
You see what I'm saying? So like we use a torque plate, and then we bolt, literally we torque anything that's going to be attached to the motor, we torque to it when we do all of our machine work. So that basically we emulate the cylinder head being on there and everything, the crank and everything being in there. So that way when we machine it straight, when we take everything off, our numbers are off. But when the head goes back on, our numbers are going to be exactly where they need to be. So it's critical to do that, especially like main hard. I've seen a couple of those where guys have done main studs, rod bolts and stuff like that, trying to do like preventative stuff to their motors, and they never run. That's like the kiss of death, man. You want to talk about movement? Rods move a lot. Mains move a lot. You know, like it's crazy. Like from the change of clamping force or load from a bolt. You know, it's incredible how much that stuff starts moving around. So some guy goes in and they're just trying to make their car more reliable, and just make it worse.
So when you're choosing materials and stuff for this, what would be better for my engine, an aluminum or an iron block? Right now I run a built iron block in my car.
I think
But it comes with its downsides of weight and everything.
Some of it's personal preference, but I think aluminum wins all the time, right? I think, like I said, LS3s are inherently not the strongest blocks. The liners are pretty weak, and it's kind of really luck of the draw. You know, I know some people that build those things, like other machine shops, and they literally they'll order a ton of them, and they'll go through and they'll sonic test them, and they'll make sure, like, and they'll make sure that they'll check, because, like, you know, when they're made from the factory, you know, they just bam, pop 8 holes in, pop the liners in, and then it goes, and then it gets straightened. So, like, when you're actually cutting them, I mean, they're just all over the place.
I've seen actual videos of that where they're uneven and stuff.
Crazy.
It's kind of weird.
Yeah, it's nuts. So you have to go through and you have to check and find a good block when you're, like, doing boost or something like.
What do they do with all the other blocks?
Send them back.
Really?
Yeah.
Oh, wow.
Just return them. You know, like,
that's crazy.
Sometimes you have to filter through stuff that way, but like I don't think you should be building, you know, like really high horsepower LS3 stuff anyways. But like I said, it's application specific, right? Like, in your situation, you're never going to have an issue with a liner, right? So, like, you're not throwing forced induction into the equation, right? You're not trying to make power that's far exceeding the parameters of what's allowable. So you're not going to have any issues with that, right? So there's no reason not to use an aluminum block. Like when we talk about, like, thermal properties, like its ability to cool faster and things like that, there are inherent advantages to aluminum. Weight is a huge one. So there's a lot of advantages to aluminum, and there's in your application and what you're trying to do, I don't feel like there's any advantage to iron.
Now, I was talking to Wout, and Wout has a lot of opinions, I'm sure you know.
Absolutely, 100%.
He told me something, I might have misinterpreted, but I think I understand what he was saying, is that it's kind of hard to, like, explain to an audience maybe, but I'll try. An iron block engine is better for heat because it retains all the heat within the block and doesn't let it out, and allows it to transfer to the radiator where it's supposed to, and have the radiator take care of all the heat, so you're not radiating the heat randomly into your engine bay. Especially if you have, like, a rear mount radiator set up, it pushes all the heat back into the radiator and does not overheat the engine bay, and you don't have all that trapped heat dealing with the rest of, you know, everything else in your engine bay. Now, does that make any sense to you?
So
Because you know how people explain stuff to you and you have to sit here for a minute and be like, I don't know what to think about that.
Well, that's a smart guy, man.
He's a real smart guy. So I was going to say, it's just a different way of thinking about things, and it broke my brain.
But I'll go the other way on this one. Why not?
But obviously, an aluminum block would radiate all the heat out.
Let's entertain this.
Your radiator wouldn't have to do as much.
What's going to be the hottest point in the engine?
Sorry, Wout, if I misinterpreted that. Keep going.
So we got to think, like, so we have the compression cycle of an engine, right? The stroke of, like, right? And where's going to be the hottest point in that engine, right? And it's going to be where it combusts. And where does that combust at? It's at the top of the stroke, right? And then it pushes that heat and gases right out the exhaust, right? And typically the hottest point is going to be there, and the next is going to be in the exhaust ports of your cylinder heads, right? Because that's going to be the hottest point, and that's what's going to radiate the most heat, not down in the block. So, I mean, if you had that much heat, what about your oil? Your oil sits in that block, right? Like, I'm going to disagree with that, right? I think that the difference in engine bay temps are negligible and manageable. I don't think that's really something that I would be concerned about. I know he has a lot of reasons for wanting iron blocks. I know he likes the lower center of gravity, like you're putting weight. But I think if you don't have to put the weight, why would you even add it anyways, right? Unless you were much heavier in the rear and your weight distribution could be better, right? Then it's a good place to add weight because of how low you're placing the weight in the vehicle, right? So it does make a lot of sense in that application. I guess if you had enough weight in the back of the car and you were disrupting the balance of the weight of the car, and you were happy with having the weight in the front, then absolutely it would be a phenomenal place to add to your car. But like I said, that is very dependent on the vehicle and how it's set up, right?
How about the block and the heads being made of the same material so they expand and contract at the same rate, as opposed to, like, an iron block with aluminum heads and stuff?
I mean, the thing is to say that they would expand and contract at the same rate is I guess a little bit more appropriately, they would be a little bit closer in line, but in reality, that's not really a problem, right? Like if you have issues with that, like cylinder head contracting at a different rate than the block or whatever, then typically you wind up being in a situation where you need more clamping force. And that's where like ARP stuff comes in hand, and that's where you have like 6 bolt heads and things like that, where like you have more hardware clamping, you have more clamping force, and they go with larger diameter hardware or even better grade hardware and things like that, so you can work your way up into that, where that doesn't become an issue. I mean, that's another reason to have aluminum cylinder heads, is their ability to dissipate heat, because so much of that heat is in the cylinder head. That's where the combustion chamber is. That's where all that explosion of heat is going out of, and that's where the majority of the heat is. And it's the preferred material for your cylinder head is aluminum by a mile. And that's where
Is it really for heat to radiate out of the material itself and not straight out the exhaust or through the water or anything else?
It's not
is
necessarily,
it not just because
but the thermal properties of it is much more reliable. Like I said, for not retaining heat, you know, like that's one of the bigger reasons for using aluminum.
Okay.
Is its ability.
I guess we would never go to an iron head anyway, so it's not like that's even a conversation.
It doesn't even really exist.
And really, I think most drifters would rather have an aluminum block than an iron block.
Like you have other reasons, corrosion, things like that with aluminum, especially cylinder heads and stuff like that. If you wind up in areas where there's water, like we hit snow or whatever.
I was going to say also in Wout's defense on that, like a small block Chevy has a much lighter iron block than an LS iron block, does it not?
Yeah.
Yeah. So I was going to say he would normally use like a small block anyway, so it would have different weight properties.
I mean, he's into all of it, anything with push rods and 8 cylinders, but he's driving a BMW with a BMW engine in it, so I don't know.
It's working. It's working.
He needs a V8, man. I don't know. We gotta.
Do you mess with small block stuff at all?
Yeah, here and there. Everything from small block Chevy to Ford. Try to stay out of a lot of that stuff, but it's really hit or miss, man. Like for a while there, we were kind of just taking whatever came in the shop, whatever came our way, because I'm kind of a sucker. And if someone comes in, they got a good story or sob story or whatever, I'm like, yeah, dude, I'll save this thing and yeah, bring it on, you know, like, and then it's an absolute disaster jumping from like different platforms and things, even jumping like with my machinery, you know, jumping even from small block to LS or whatever, you know, like I had to change all programs, fixtures, everything. So we don't do too much of that stuff, the small block stuff. We don't do a ton of LS stuff either, you know.
You don't?
No.
Oh, I kind of just assumed you did.
It's kind of like every machine shop, right? You can't get away from it, so we do it.
Yeah.
It happens. I do it for myself, and like I've done it for customers, and but there's just a ton of people specializing in LS stuff, right? You're in Texas, right? You throw a rock, and you hit like legit machine shops that know that motor like the back of their hand. And I mean, we've done everything in the shop from like the Chevy LS platform to like we've done like Ford stuff for like Pro 2 trucks, Pro 4 trucks. So like big like NA, like 930 horsepower, naturally aspirated V8 stuff. So we do like that kind of stuff to like supercharged LS stuff. But I like to do a lot of the import stuff because I feel like there's not a lot of places for those guys to go, you know? I feel like a lot of the machine shops, they don't want to deal with it, you know? They don't care. They get just like, fuck, another import engine and fucking whatever, you know? Like,
when you see the scale of like how many engines Texas Speed puts out compared to like an SR shop,
oh God,
you understand.
Yeah.
I mean, you own a machine shop. It's like.
I also believe from where I'm at, like from a business perspective, right? Like, and I'm not pushing the machine shop very aggressively. We're just kind of like, it's more of like a hobby thing. Like right now, it's just kind of something on the side. It's kind of like growing legs of its own, you know, because we're putting out motors and they're working, right? So like, and I like being able to solve problems that other people are struggling with. Like, let's just say, for instance, like a 2JZ, right? Like Forrest, right? Forrest having problems with just trashing oil pumps. And granted, the real solution was dry sump, right? But he was just trashing them, and that was a big problem, just seizing up engines. And it's happened. There's another guy, Farouk, went through what, like 7 or something motors in like a season. A lot of these guys they're all having the same problems. You know, the thing is there's people you could go, places you can go. Like, so if you just go to Texas, just throw a damn rock, and you can hit somebody that knows what they're talking about and knows LSs, right? But like when it comes like 2J stuff and things like that, and like drifting, specific stuff. There's really nobody like kind of addressing that, right? So I would rather try to find solutions for problems that are real, that exist. You know what I'm saying? That people are still figuring out, right? So what we did for a 2JZ, like after going through these motors and looking at them, what we had realized, and this was a difficult thing to figure out, because when these engines, they get surfaced, when we're machining them, we deck the blocks, and we don't get to see where, how much material gets taken off, because these were done at another shop. So I have no way to reference, like, I have nowhere to reference that's consistent and precise enough that I feel comfortable with, of like where the crankshaft is, right? But what we had determined is that there wasn't a way to cut billet main caps on a JZ correctly. So everybody's using an Align hone, which is exactly like, people think it's like a line hone, but it's a line hone, right? And basically what it is it's a mandrel with a drill on the end and just stones, right? And then you go back through, and they rotate, and there's a shoe on the opposite side. It rotates in a perfect circle. So basically you cut the cap down and shorten it, and it makes the hole smaller. And then you open it back up to make it perfectly round again, right? And that's basically what this tool is designed to do. Now, it's designed to take off very small amounts of material, like, thousands, I would say even tens of thousands, right? Very small. You're supposed to cut it till the hole barely shrinks, then size the opening, right? So you're only supposed to shrink it just a little bit, make it round again. And that's how this thing works. But this thing has no memory. It's not a machine. This mandrel isn't attached to anything rigid. It's kind of loose, right? The shoe on the other side holds it, and then you have a drill. So basically since it has no memory, it basically is always going to follow the path of least resistance. So when you have two different grades of materials, you have a billet steel on one side and you have cast iron on the other. The billet steel is considerably stronger. So it's going to want to push away from the billet steel and more into the block. So now you start shifting the crank into the block further and further and further, depending on how much material you take off, right? And so there's also a tool and a fixture made for that with a single bit cutter. Problem is it's unstable. So most guys I know that use those, some guys are really good with them. They'll cut with the single bit cutter in that same machine, and now they have an actual physical boring tool for it. Very uncommon to find these, but you could send them through. But most guys I know leave about 5 thousandths to size before they stop, and then they finish with stones, which again is going to shift it. And I've actually talked to other machine shops about this, and they've confessed to me that they know that they're moving them. He's like, there's just no other way to do it. Okay, cool, we'll find a solution. So I actually worked with Rottler to develop. There's a tool it's existed for a while now, but it comes down, and then it's like an arm that comes down, and then it turns 90 degrees, and then that part spins with a single bit cutter. So basically it goes in each journal and then comes up and then cuts each one at a time. And then you have a single bit cutter that goes in there to make it perfectly round. So with my CNC machine, I could set the height perfectly. I could literally cut all the material out of caps and never touch the block. Like I could tell, and then at that point, like let's just say like the block was distorted or had damage or whatever, I could cut 1,000th or like half a thousandth into the block, right? And I know that if I go oversized on my cutter, I'm gonna go half a thousandth into the block, half a thousandth into the cap, and then make an oversized bearing, and then my crankshaft's back centered perfectly, exactly where Toyota left it, right? So that's important because you have an oil pump that is located on dowels. So when you locate on dowels, you have no ability to move this oil pump. And you're relying on these gears to be perfectly in line with each other. And if you have no ability to move that pump, when you secure it down and that crank moves, now your tolerances in your oil pump gears are no longer good. So it's just going to generate more heat, eventually lock up on you. So we figured out the problem. We found a solution to it. Obviously, my solution, the real solution was dry sump. Obviously, you're forced weighing, you're making 1,000 horsepower, you're driving Formula Jiff, you don't have a dry sump, you're playing the wrong game, right? Like, you're kind of wasting your time. You should really be on dry sump at that point. But for these guys that are running these we found a solution. So that was like a cool thing that we were able to accomplish. That was a solution. And there is another machine shop that I know of for sure, maybe more, that have actually purchased that tool because Rottler afterwards had added it to their catalog. So any machine shop can get this tool. It's like $25,000 or something, $26,000, $27,000, whatever it is for the tool. Then you need like the different heads, the cutters. I mean, it gets pretty pricey. It's not a cheap piece of equipment to just do one little job, but there's no better way to do it. I can cut mains in any block accurate to 1/10 of a thousandth. So pretty ridiculous figures when it comes to machining. I could set your bearing clearances, everything, if I know the shell thicknesses. I could do so many cool things with it, which is awesome. And then we could eliminate that as a potential problem down the road. But this is a problem a lot of guys were going through with the progression of JZs, especially what I saw in drifting is I need billet mains. And every single time it's like you have a guy that, you know, I use Farouk, for example. I haven't done any work for him. He's been talking about sending me some motors, but he was telling me that, like, I said, what's your problem? And he's like, well, you know, like I'm running 700 something horsepower. I do a whole season on a motor. Everything's great. I switch, I say, you know what, maybe I need a little bit more horsepower. I'm worried about my main caps and concerned. I switch to billet main caps. Every event I blow up a motor. And it's like, well, if the only thing you changed from here to here is billet main caps, then maybe I'm not wrong. You know what I'm saying? Like, so like I said, I like finding that. So I like the fact that it's niche. I like the fact that there's not a bunch of people developing stuff for it that I could go in and I find it more enjoyable. I enjoy doing cylinder heads on 2JZs and stuff more. This is so intricate. Most people don't want to deal with it because nobody wants to pay. You know, it's like, oh, I need I need a valve job on these LS heads. Like, sure, it'll be, you know, $200 or $300 or whatever, right? It is, I don't, whatever, $300. And then someone comes in with a JZ and I need a valve job and I'm like, it's $700 or something, you know? And they're like, what the hell, man? It's only one head, but like, it's just that much more work. So a lot of people, shops, they just don't want to deal with it because the customers, they expect it to be the same or less than something else. They just don't understand how much work a solid lifter overhead cam cylinder head is. It's terrible. And I mean, there's shortcuts and things like that, but obviously we try to avoid that as much as possible. We want to make sure everything leaves the shop perfect, because reputation is worth more than anything. You know, obviously if I ever want to be successful, you know, machining, or if it's something we decided, you know, go full bore on or something. And I mean, we have 3 employees. I mean, we are turning over a lot of, you know, a lot, but we're not Texas Speed. I guess my scale of what's like a large and like a hobby might be a little bit construed with some of the shit I got going on, but I mean, but I mean, reputation's everything. So like wherever I want to go, even if I want to stay small, big, whatever, your reputation is everything. You have to be able to stand behind the products you put out and warranty them. But that's another reason why, like, you know, like let's just say in your case, right? Like, and you were like, hey, Chris, I need an LS3 bone stock, right? And you bring me an LS3. I'm going to say I won't do that, right? And the reason is because I can't go buy GM pistons, right? And OEM GM pistons are not. I can never replicate a short block. You know, like it's more expensive. I can get forged pistons way cheaper than I can get OEM GM pistons, oversized pistons. It's ridiculous. So like the stuff new from the dealership is crazy, but they're what's it called? Their crate motors are a great deal, but the parts individually in the crate motor, terrible deal. So I can't replicate that. And one of the main reasons is I can't stand behind it. I can't warranty it. And because I don't have horsepower ratings or support, right? Like GM, if I call GM and say, hey, I want to buy these oversized factory pistons from you, and then I'm going to put in this motor, this guy's going to go drift in Japan. I need to know that if this piston fails, that you're going to stand behind me at these power levels, right? Or like, let's say piston rings, right? If I get blow by or if anything happens with these piston rings, right? I also need to know the profilometer readings that are required for the proper finish on a cylinder, right? I need to know my crosshatch angles. I need all this data. They're not going to give me any of that stuff, you know? So this is all data that I don't have access to, which I could come up with numbers that are going to work for that piston, that ring, and I can make that work 100%. But I can't stand behind that, right? So like, let's just say we build you a forged motor, right? We would forge pistons in there, right? And rods, right? I can call those manufacturers and say, like, this is what we're doing, 400 horsepower, whatever. I need a rod that's going to withstand that. I need a piston that's going to be able to withstand these power levels. Obviously, I know which ones they are, but because I've already gone through this so many times that I don't have to call and ask anymore. But I find things where like they'll stand behind me, right? And another crazy thing is like we'll usually use pistons. Most piston manufacturers sell them as optional. Some they come with the pistons like Manley, but like Total Seal top rings, right? Total Seal, I can literally call Total Seal. They have the same CNC cylinder hone that I have. They'll give me the profilometer readings, everything I need, right? And if I could hit those numbers or beat those numbers in my cylinder hone, and anything happens that's related to those rings, if you get a drop of oil and blow by, they will stroke me a check and pay for all the machine work, all the parts, and everything to do it again. They are that certain that if you do this way, and at the end of the day, numbers just don't lie. And that's the thing is if your machine shop's putting out bad work, is they don't have the gauges. They're not checking things properly. You know, and that's 99% of machine shops, unfortunately. But you know, I have criteria I can meet where, like, if this thing goes through some sort of catastrophic failure, I'm out labor, but I'm not out parts. You know what I'm saying? So, like, I can say, like, I could then stand behind and support that engine. You know what I'm saying? I can say, like, okay, like, this is the engine. You need to, once a year, season, take this thing, we'll tear it down, we'll go through it, or re-ring it, things like that. We'll stand behind it. If anything goes wrong, we'll take care of it. I could offer you a level of support that you couldn't get somewhere else.
Should I be doing all that? Because I definitely don't do any of that.
No.
Okay, we leave everything in the motor. We don't check anything. We change the oil.
I don't either. I'm not racing competitive.
Okay, I was just saying, like, these are things that I'm not doing.
You hear me just limit or bang, and
I agree. I just hear you say, like, we should take apart the motor every season and check
well,
things.
Like, if we're running like a fully built motor and you're like running competitively, right? Like, this is, I guess, general, because most of the people out here are trying to do Pro-Am, Pro-Spec, Pro-1, or whatever it is, you know? These are things, if you want to make sure your motor's there.
I want maintenance free.
But this would also be like the point where, like, the reason why I say this is this would be the point where I would support you and I would discontinue support. Like, I wouldn't say, like, okay, like in your situation, right? We built this motor, right? Like, and I would say, like, look, if anything happens, I'll take care of it, right? No problem, no questions asked, right? Bang. This point. Okay, this is the point where we should be refreshing this motor. Like, if we were a professional racing, we're not. I understand that, right? And I would say, like, okay, if you keep driving this motor, it's on you. You know, it's already made it a full year, full season, but it's on you. Like, I'm not gonna come out of pocket, do whatever to replace, like, if anything happens from this point. And I don't see the reason why you couldn't just keep driving it at that point. Like, we've had motors. We had a motor. There's a guy in Vegas that got a motor from Justin, my partner, that we had, and we pulled it out of a Pro Light truck. The guy was supposed to have this thing gone through. He won. He built this motor for him. Went on, won the championship. Goes in. We're supposed to tear through it. Guy doesn't want to do it. Next year goes out, wins the championship. What the fuck? Take the motor down. You know, Justin's like, yo, you gotta tear this fucking thing. We gotta go through this. You know, I'm not gonna drive next season. Next season drives. Wins championship again. Like 3 champions with Jesus Christ. Pull it out, and then, like, someone's called me and needed a motor, and I'm like, look, we have this motor here. It really needs to be gone through. You know, like, it's won 3 championships. It's legit, but it's. And he was like, okay, yeah, sure, I'll buy it. Doesn't go through it. Puts it in a drift car. And it's just bombing the thing. I think he took it out because it was smoky. Well, it wound up just needing valve seals. But it definitely needs to get you know, like, that's a little, like, I can't warranty that because, like, this thing's done 3 seasons of competition, and now you're out here, you know, railing on a drift car. Like, I can't. This is like, so, like I said, like, when things come fresh from my shop and they're new, and you're getting a high performance motor and you're putting in your race car and you're expecting results, like, I'm expecting them too. But if you don't take care of it, I can't stop everything I'm doing if something happens and fix it for you. You know, like, because you're outside of that window of what, like, so, like, of what I would support, right? And it's because I think that they should be gone through. But, like, if you were racing, but if you're not racing, if you're just a guy, like I said, my own motor, I don't do that. Like I said, but I will also, like, I'm beating the hell out of my car. I did last drift week. I'm doing this drift week. If something happened to my motor, I know why. I know maybe it could have been prevented, maybe not. I don't know, right? But, like, I know that that's my own fault, and I take responsibility for that. You know what I'm saying? Like, if you just say thing, like, you take a GM crate engine, right? You know this engine is, you know, like, not designed for drifting, right? But we use it for drifting because it's a fantastic motor, right? You're not going to go, like, sit there and bang limiter and run a season on it, and then something happens and call Chevy and be like, yo, can you warranty this?
They do, don't they, though?
Do they?
I would assume so. How would they know it's in a drift car?
Yeah, I guess, but I guess you could use the factory ECU and everything, huh? They've used, like, the whole drop-in.
How would they know what ECU that you have on it?
I can't afford to do the things that Chevy does. I'm not that big, you know?
So, is there a better motor than the LS3? I think they're like 5,500-ish, 54 to 5,800, I think, online. Is there a better motor that you can think of that's a crate engine?
No, for drifting.
Yeah.
Like we're talking like 400 horsepower. No, I mean they're what.
And they're so much cheaper. Like if you look at a Texas Speed engine for even just another 150 horsepower or something like that, it jumps up to 12,000 plus.
Yeah, and then you look at like
their bang for the buck is insane.
the next step. Like so, basically displacement's king, right? And then the ability for a cylinder head to move air, right, would be next, right? So displacement and then volume in the cylinder head, right? So your next step up is LS7 and displacement and cylinder head capabilities, right? That is a massive jump in price, a massive. I think the crate engine's got to be like 18 grand or so, something absurd, right? But you got like titanium rods. I mean, those rods new from GM are like $6,000 for a set.
What?
They're titanium rods.
I didn't know that.
Yeah, they use like a special coating on the outside. Like
Quick question, were all the LS7 valves shitty, or was it just like one generation or something for the LS7? I keep interrupting, sorry, keep going.
Then there's a lot of people, everyone has a different idea of a little bit different version of like how this went down. The initial failure point, I believe, was like the early models, like 07-ish or something like that. And a lot of it had to do with the coating they were putting on the valves, right? So like, you're not supposed to technically be like, and this is what's impressive about some of these coatings, right? You have two connecting rods right up against each other sharing the same journal. And they put this coating on there that allows them to operate and live side by side with just oil in between them. The second that coating is gone, they eat themselves alive like that. Like the coating is that good and that durable. It's impressive, and they do the same thing like valves. You can't face, like, so when I say face, like you have your valve and then you have like the head of the valve, right? So the face would be the top surface that meets your seat, right? You can't face a titanium valve that comes out of a GML because they're coated, right? Because you can't technically run the titanium on like steel, ductile, aluminum, nickel, chrome, whatever blend seats, whatever they're using in there, right? You can't run titanium on there, it'll destroy it. But they put a coating on there that allows it to be able to seat up against it and bang up against it and not eat away at that material, which is impressive. But the problem is so they had a couple inherent issues, right? So they had a machining issue, which was early on, which was some of the guides were machined like off center or whatever, the holes. So they had some issues with that. We had issues with coating and the coarseness of the coating. From a longevity and a durability standpoint, powdered metal valve guides are incredibly strong and they work really well. From a lubricity standpoint, its ability to retain oil, they're terrible. So on proper materials, so proper steel valves, they work. But on titanium with coating, they work as well if the coating is correct, but the coating wasn't. It was wearing the guides out prematurely to where you could you get a bad head, you could just sit there and just wiggle, even with the rocker arm in there, you could just wiggle the valves around. And they just got all this side-to-side play in there because it's eating away at the valve guide. And then you also have, it's like with steel valves. And so basically, what happens is you're creating all this this deflection of the valve train at high RPMs, and then a tip breaks off, and that valve goes down into your cylinder, and then that's it. That's that's catastrophic. Nothing salvageable at that point. And so that's the biggest fear. There's problems, same thing with like the exhaust valves and stuff like that, like coatings and stuff like that, because you have powder metal guides. So the typical fix for that is bronze guides. Anytime you use a valve that's stainless, Inconel, anything of that nature, you should really have a bronze guide because its ability to retain oil. And that's basically the only thing that's stopping your valve from slapping the side of that guide inside is the oil in there. So its ability to retain oil, the lubricity of those materials, those bronze materials, are so far greater, it doesn't last as long as it's a softer material. But in situations where you're running things like stainless that aren't as slick, that are coarser, I mean, they look polished, but I'm not like a metallurgist either, right? But they look polished, right? They look slick, but stainless isn't anywhere near as slick when polished as steel. So you need to have that extra oil in there, and you have to have a bronze guide. So like my car, no problems, factory titanium valve, just uncut, untouched, they're good shape, and then new stainless exhaust valves and bronze guides, and then CNC ported, obviously, and some other stuff, and no problems.
From a cost for bang for buck thing, that LS3 is like literally 80. It's 6.2 liters as opposed to 7 liters. It's 80% of the engine probably at 1/3 the price.
Easily.
Or half the price.
Yeah,
1/3.
probably.
1/4. I thought they were like 12 grand. Are they 18?
LS7s are expensive.
Dang.
I don't know, maybe they might be 15 or something like that. I don't know. LS7s are not cheap at all. They made some other configurations. They made like a non-dry sump version. So there are some configurations for the guys that aren't dry sump, that just want a wet sump. So there is a wet sump version of the LS7 that you can get in a crate motor. I think it might be a little bit cheaper, but still, it's probably they're probably 3 times the cost of an LS3 crate motor. So it's like when you compare the two, there's just no comparison value-wise. It makes no sense.
And what's the failure mode of an LS3, do you think? I keep pushing him on all this stuff. Again, this was a scam interview to get a bunch of information, and then he gives amazing information on everything as we go through, so I love listening to this. I'm not bored, by the way. I'm just like curiously listening to him. Keep going.
Like drifting, as long as you can keep everything under control, I would love to see it on like an aftermarket ECU, would be preferred.
And why is that?
Fail safes and things like that.
Oh, okay, yeah.
You know, like
so you can have a limp mode kind of thing over a certain amount.
And then make sure that, you know, we check things when we get to play. Like I said, you go to Japan, conditions are a little bit different, probably, you know, check on those things and make sure they're good. And I don't really see too many things failing on an LS3. I think the first weakness drifting is going to be lifters. You know, and the design of it, I don't see like a lifter, like it causing too much damage. If anything were to happen with a lifter, it would take a long time. Even if a lifter wasn't keeping them up or whatever, I could see it damaging the camshaft, damaging things that are easy to replace. So it's really not the end of the world pushing your luck with the stock lifters, because that stuff is fixable. You know, like the things that it could damage. You know, they sit deep enough down in the pocket where I wouldn't worry about slapping around in there or whatever and actually damaging the block and stuff, especially with a stock cam. You know, like obviously with aftermarket cams, anything's possible. You definitely open up the realm of possibilities when you go and you throw a lot more lift at that factory lifter. But yeah, I mean, realistically, like valve train would be my first place I would look. I would look at push rods, and I would look at, those would be my first failure points. Obviously, like its ability to deal with, you know, detonation, things like that, you know, things that happen and break.
Like 100 octane fuel over there.
Exactly, you know.
Yeah.
It's not going to be as capable of handling those things as like a built engine. But usually, like I said, those aren't typically like, I'm not expecting to come out here and deal with like a bunch of detonation. But like I'm on drift week and I'm not tuning my car and I'm getting some detonation, things are happening in my car places, and I'm running it hot and I'm doing things I shouldn't be doing, which are changing the parameters, you know? Your temperatures run up and you got to get that one more pass or something like that. Like things can happen. You don't have to. You don't have to.
You're like, but I'm gonna.
But I'm going to. I don't know about you. Maybe you have more self-control than I do. I don't have.
I have a crazy rear mount radiator and all that stuff. My car doesn't get over like 190 most of the time.
Then you're fine.
Yeah.
You know? But yeah, I think that you're there. You're, you know, like I think that you are in kind of like a crate motor kind of territory. You know, your power demands aren't really there. You know what I'm saying? Yeah. Like especially in Japan. Like why wouldn't it work? How many cars do we see out here with factory motors shredding for however long? Even LSs and stuff like that. The Corvettes. You know, we talk about these Corvettes, but it's like, you know, all the Corvettes, someone's had their hands, they're blowing up, someone's had their hands all up inside them. So is it far? And we're talking about how many miles were on that motor, you know what I'm saying? Like,
I think 70,000 or something.
We're talking about versus a brand new crate motor, you know what I'm saying? Yeah. So like, you also got to figure there's been a lot of wear and tear on some of these motors, you know, but.
I just want permission to put LS3 crate motors in there and know it's going to work.
Yeah, I mean, obviously, like I said, racing, right?
Because I normally put built motors in there.
Yeah.
You know, I just give them to machine shop, trust them. And honestly, that's probably a lot worse most of the time. Probably most machine shops are worse than GM. Do you agree with that?
Yeah, so I think like, if I could give somebody advice, and probably if you did this and you weren't building like a real engine, like an actual race engine, you'd probably just get laughed at. But if you were building like a race engine and you're just gonna go to a machine shop, whatever, like let's just say you're getting your cylinder head surfaced, you know? They should be able to give you the RA finish of that surface job. which is basically you take a profilometer and you run it on the surface of the cylinder head. It tells you the RA finish of it. These guys in Vegas, man, they should be coming out looking like nail files, man. I don't even need a profilometer to tell them it's junk, but you should have a profilometer. You know what I'm saying? Like a machine shop should have a torque plate. You know what I'm saying? Like, and you know, like these are basic things. You know, like they should be able to, you know, help you. Like they should, give some of the profilometer readings on a cylinder bore. You kind of have to trust these guys, but at the same time, like, if someone came in with like a legit enough program and asked the right questions and wanted like profilometer readouts and stuff, I would give it to them. You know what I'm saying? But it's only because I do this on a regular basis, right? Like I measure things on a regular basis and I upkeep my shit. But most of these people, if they tell you no and they're like, oh, fuck off, it's probably because they don't want you to know the answer because they're going to be wrong, you know? And like I said, 9 out of 10 machine shops don't even have a profilometer inside them, which is absolutely mind-blowing. It's just like some old dude that's like, oh, I've been doing this for my whole fucking life, you know? I know what the finish looks like that it needs to be, you know? And I'm like, okay, but there's like a digital fucking gauge that tells you exactly what it is, exactly what your crosshatch, everything, you know? Like, so like, those are things. And then, you know, to be honest with you, dude, it's 2022, man. Don't be afraid to ship your motor somewhere, man. You know how many times people come in my shop looking for a motor like you? And I tell them, and I'll sit there with them, and I'll go and fucking like, some and shit, I'll find them a crate motor. Before I even take their motor. No, dude, like you don't, because I'm gonna tell you no, and you're gonna leave and you go to the next machine shop. Sit down, and I'll show them where to go find a crate motor or something like that. That's right for their application, right? Rather than spending the money with me.
How many people bring you exactly what you're talking about right now? I should have bought on this motor I'm rebuilding right now a LS3 crate motor. It would have been better than the motor I gave to this machine shop because the bill got insane. How often do people give you motors to build only because it's cheaper than buying a crate engine or something else, and they're cheap? Not many, or everyone? Or?
Yeah, usually those kinds of people, they have their own parts and they have their own way they want things done, and they could just go somewhere else.
Yeah.
Because the reality of it is if I can't stand behind the motor, it doesn't get assembled at my shop. I don't need the money.
Yeah.
You know what I'm saying? And reputation is everything. So I would rather just continue to put out quality motors.
So you don't work with drifters?
No. Surprisingly enough, I do. I have a soft spot, man. I have a few in my shop now that are mind-blowing.
Yeah.
Like mind-blowing. Like how bad. Like I'm talking like just built by another machine shop. That I'm just like. I have a kid in my shop like literally just got his motor built. I mean, it was destroyed. I mean, everything. I'm talking pistons were ruined. Rods ruined, blocks ruined, heads ruined. I mean, they like everything on the whole entire motor was destroyed after they got done with it. It made like 1 or 2 events and just ate itself alive. Just do the pistons. We flipped the block over. The pistons just fell out, and we're just like there's like, unbelievably like the worst work I've ever seen. And I've seen some really bad stuff. I had another guy bring me an LS that he had rebuilt at some other machine shop. I don't count this one as a machine shop because they're like the north side of Vegas. They're engine rebuilders, like whatever, and they $1,200 rebuilds or whatever. So it's like I don't call this a machine shop because nobody in the right, anybody that drove by this place would be like, yeah, I'm not having my race engine built there. It's just for rebuilding like factory stuff. But this guy, $1,200 LS rebuild, no problem. Wow, dude, like, holy shit. Instead of washing it, they just spray painted all over, all the dirt, everything. And especially because they made a mess because every gasket they reused, they just coated in like this hydraulic hose sealant and then put it back on. It was like oozing out everywhere, but they spray painted silver back over it. So, oh, dude, it was the worst thing I've ever seen, man. I see a lot. We just did a K-Series that was sick. They did like a F22 crank, F22 rods, F20C pistons, 2.0 stroker. They didn't cut the skirts on the pistons far enough because it's so close to the counterweights on the crank. So they were trying to machine the skirts down when they should have actually turned the counterweights down on the crank. But if you turn the counterweights down on the crank, you might have to add heavy metals back in, which gets like really expensive to compensate for. That's probably why they didn't want to do it. So this guy was ripping this thing, and the piston made contact. We open this thing up. It's got like the little tamper-proof things from like the oil cap bottles were like in the pan, and then the pickup was clogged full of paint. So like instead of cleaning this thing properly, they painted the outside of the block and the head. Well, they also painted the inside too. And so the paint starts flaking off. It just clogs the oil pickup up. And you're just like, what the fuck is wrong? Like, I get you want to, like in my shop, like some shops they use most shops I see they use like glass or sand media. And I know every single one of them is just like waiting for the day something's gonna come back fucked. Because like there's a good chance that you could leave one grain of sand or one glass bead behind that you don't see and destroy everything. Especially on import motors. Like domestic stuff, no problem, right? You could pull the oil galley plugs and it's straight through. A lot of import stuff, they turn, and you can't get to everything. So they just sandblast, bead blast all this stuff. And they have a brand new looking product for the customer. The customer's like, oh my God, my head looks like brand new. But and then you have the shops that don't have the equipment, and they just spray paint it to make it look brand new. My finishes aren't ideal, like they look really good, but they're not like brand new looking, because we use baking soda. So like everything gets blasted with baking soda in my shop. I don't put glass beads or sand in anybody's cylinder heads, man. It's just, like I said, I leave one grain behind. So everything gets blasted, and it does a phenomenal job. Just doesn't look as bright maybe as like some of the other processes. But we exclusively use baking soda, so that way we can't leave anything behind. And if someone's like, dude, I need my head to look brand new, like shiny, like the other machine shop, they go to the fucking machine shop. Because like I'm not dealing with it, like, because like I'm just not gonna take the risk. You know what I'm saying? Like I said, reputation is everything, man. And that's all you got sometimes in this world, Otherwise, like you start tarnishing your reputation, then I'm just another machine shop doing General Automotive like these other guys, and I hate myself and destroy people's shit.
Well, thank you so much for sharing with us and stuff.
Absolutely.
I don't want to take all your time because I think we're about to shut down track.
Oh yeah, we probably
I monopolized a bunch.
Are we gonna stick to this layout till the end? Just run it to the.
Well, since I'm not accurately out there doing stuff.
Oh fuck! Never mind. It's 4:40. Yeah, we're done.
Okay.
No more drifting.
I don't even know how long we're going today.
5 o'clock.
Oh man.
13 minutes.
All right. Well, I gotta go shut down. Thank you very much for sharing all that with us.
Of course, man.
What's your machine shop's name?
Just Racing.
Just Racing. Can I put that at the beginning, or you don't want anyone to know the shop name?
They can know the shop name. I don't care.
Okay. Thanks, Si.
All right.